Welcome back to the session again. This is Ballu Harish. Now we are going to discuss about the image classification. What is an image? Image is said to be collection of pixels in rows and columns. Each pixel is having different reflectance value based on the radiometric resolution. Hope that these things are clear to you. Next, now we are going to discuss about the image classification. Okay. How many types of classification techniques are there? We can say that the classification, it can be done in two different ways, or also some other advanced high classification techniques are there, but just today in this session we are going to discuss about supervised and unsupervised classification. Okay. Mm, what is basically, first we start with the meaning of classification. What is classification? What do classification stands for? Classification means identifying the number of features in an satellite imagery and saying to which category that particular feature belongs to. Suppose if you have taken a study area, in that particular study area there will be some land use, land cover, forestry, some linear features, all of them will be there. So we need to identify each and means using the classification techniques we need to interpret to which category the particular feature belongs to. Okay, this is about classification. Classification means just uh, providing information about each and every feature present in the satellite imagery to which category it belongs to. Okay. It might be either land use, forest, or some other water body, or scrubland, barren land, to which category it belongs to. That's the concept of the classification. This classification, it can be done by two different ways. Today in this session, just we confine ourselves to two things: supervised and unsupervised. What is supervised classification? What is the difference between supervised and unsupervised classification? Means in case of supervised classification, human interaction is needed in each and every step by giving the output. From giving the output to getting the output, till all these cases human interaction is needed in supervised classification, whereas in case of unsupervised classification the computer system will take care of. Okay, just now in this video we are going to discuss supervised classification. Next will be in the next video you are having a lecture of unsupervised classification. Okay. In case of supervised classification, we mainly come across the classes training sites. What is training site means? Suppose if just before I have said that features means forest is a feature, scrubland is a feature, water body is a feature. We call forest as a training site, water body as a training site, scrubland as a training site. Okay, in a particular satellite imagery, if suppose let us focus ourselves on the water body, let us assume that water bodies are present at multiple locations. So while doing the classification using supervised classification, we need to digitize more number of water bodies which are present at multiple locations. I have digitized water body 1. Next I have digitized water body 2. Individually water body 1, water body 2, water body 3 are said to be classes. Next we need to merge all those classes, water body 1, water body 2, water body 2, 3, to a single class. That particular single class we call them as training site. Training site is collection of multiple classes. Even though a single feature is present at multiple location, we should not stop our digitization at single location. We need to choose more number of classes for a single training site. If you choose more number of classes for a training site, you get more accuracy. Your accuracy depends on the classes that you have given for a training site. Okay. Digitization, I think you all are clear about the digitization. Okay, next we end the session with the algorithms which has been used in supervised classification. What are the different algorithms? Minimum distance to mean, maximum likelihood, parallel pipe. These are the different algorithms. Which is mostly used is minimum distance to mean. Okay, this is supervised classification. Hope that the things are clear to all of you. Okay. Next, unsupervised classification. Unsupervised classification means human means system will take care of all those things. Okay, the main means we need to have an idea when should we use the supervised classification, when should we use the unsupervised classification. Okay, just do remember two things. While doing the classification, a particular user he need to have idea about the two things. First, he need to have the clear cut idea about the study area. That means what are the features that are present. Okay, by looking the satellite imagery, he can understand that particular feature belongs to which category. Okay, first he need to have the clear cut idea about, he need to be just he need to have idea about the study area. Second thing is he need to have idea about the elements of image interpretation. These are the two basic sources. Okay, suppose if you are not clear about the particular study area, try to learn from the other sources like topo sheets. Still you are not able to get, means you are not familiar with the study area. That time, instead of using supervised classification, you can go for the unsupervised classification. Okay. Next, in case of unsupervised classification, what are the different algorithms used is k-means, isodata, and EM classification. Okay, these are the different algorithms used in unsupervised classification. In this video, we mainly focus on supervised classification and its algorithms. Okay, just stay tuned. Next, supervised classification. Uh, in case of supervised classification, what the meaning of the first point is, if you are doing the classification of a imagery using supervised classification, you need to have the prior knowledge of the area that you are going to work, and you need to have the idea about the elements of image interpretation. Okay, next, what is the meaning of the second point? Conventional cover classes are recognized and seen from prior knowledge or other map layers. Means whenever you are performing supervised classification, try to choose more training sites. For each training site, try to use more number of classes. Okay, if you do in this way, your accuracy will be good. Next, training sites are chosen for those classes. Means what are the features that are present in your study area, try to use training site for all the features. Okay, next, last point, each training site class results in cloud of points in n-dimensional measurement space representing variability of different pixels spectral signature in that class. Okay, just we move to the next slide. Okay, this is the particular study area which has been classified using the supervised classification. This particular what are the things which are present in the right side, they are said to be training sites. For each and every training site, I have taken two classes. Okay, if you choose more number of classes, accuracy will be obviously good. Here, if you think what are the things which are getting highlighted by this particular green color, they comes under the tree training site. Next, this particular, it comes under some cultivated, like that. Okay, this particular training set comes under the it comes under the sediments, like that. Okay, this is how can you do the classification using supervised classification. Means I have digitized each and every I have digitized each and every training set. How can I digitize? After digitization, I need to say to the software it belongs to segment 1 or segment 2. How can I say either segment 1 or segment 2? Means if I am perfect with the satellite imagery, I can say the particular feature in the satellite imagery belongs to segment 1 or segment 2. Okay, next, one more thing I have said, that if you are you need to have command on the image interpretation techniques also. Okay, by having these two things, you can do the classification using supervised classification. Is it clear? Next, uh, here this particular cluster belongs to this training site. Next, this particular cluster belongs to some clearest, I have given some random name. Now how can we say a particular cluster belongs to a training site? Means based on the based on the algorithm of the classification, the cluster will be decided to which training site it belongs. What are the different algorithms that are available in supervised classification? First, minimum distance to mean classification. Next, Gaussian maximum likelihood classification. Next, parallel piped classification. Each of them will give slight different result. Obviously all the algorithms won't give same accuracy. All of them will give slight different results. Just one more important thing you need to remember: how can we determine the particular algorithm output is correct, or how the next one more algorithm output is not that much correct? Means based on the accuracy assessment, we can say which algorithm output is correct, which algorithm output is accurate. Okay, next, first we start with the minimum distance to mean. In case of minimum distance to mean, a center point of the point cloud is plotted based on the mean values, and unknown point is assigned to the nearest of this. That point is then assigned to the cover class. Hope that you may not understand. Just next, in the next slide you will have the clear cut idea about the minimum distance to mean. Okay, just here D is the minimum distance to mean. These are the different clusters that are present. Cluster 1, cluster 2, cluster 3, cluster 4 clusters are present in the satellite, in this particular satellite imagery. For all these particular clusters, a center point is computed. Next, based from the center point, distance is calculated to all the cluster. Whichever the cluster is near to this particular center point, it will be it will be classified to a certain criteria. This is the way how minimum distance to mean will work. Okay, first thing is center point of all the cluster is computed. Next, from the center point, distance is calculated to all the cluster. Next, the classification will go on. Okay, one more next classification, next algorithm is parallel piped. In parallel piped we come across two things: simple parallel piped and precise parallel piped. In simple parallel piped, okay, in simple parallel piped, the marking of the both in parallel piped we need to take care of the marking. In the marking features, in the marking pixels of the features is present. In simple parallel piped, the marking is done using the rectangular symbol. In the rectangular symbol, pixels are present. Okay, here cluster 1 is present, cluster 2 is present, cluster 3 is present, cluster 4 is present, and cluster 5 is present. Okay, all the clusters are placed in a marking symbol. The marking is provided in a rectangular symbol. In that particular rectangle, all the pixels are present. The main limitation of simple parallel piped is overlapping. Here if you see, there are different you can see two overlappings are there between one cluster and the another cluster. Because of this overlap we get the erroneous results, means we won't get the good classification output. Here the limitation with the parallel piped is the marking, whatever the marking is getting done by the rectangular symbol. Okay, if suppose if the cluster is present at far distance, there is no problem. But if the different clusters are present near to each other, and if they are getting marked by the rectangular symbol, due to overlap we get the erroneous result in simple parallel pipe. As this is the limitation, there is one more parallel pipe called precise parallel pipe. In precise parallel pipe, the marking is not done in a rectangular way. The marking is done in some other way. Okay, if you see, the marking is not done in a rectangular way. Here in this case, as the marking is done in smooth way, there is no overlapping between one cluster and another cluster. As there is no overlapping, we won't get erroneous results. Okay, next, one more classification technique is maximum likelihood classification. Uh, Maximum likelihood classification, it is based on the probability. Here what are the pixels that are here maximum likelihood classification is based on the probability of the contours. Here it is the contour 1, contour 2, contour 3, contour 4, like that. It can be more number of contour based on the cluster size. Okay, here what are the pixels that are present in the first cluster, they will be classified very good compared to the pixels in the next coming contour. Here the pixels in first contour will be classified correct when compared to pixels in second contour. Like that, pixels in third contour will be not that much classified good compared to pixels in first contour. Okay, whatever the pixels which are present in the outer contour, if they get overlapped with the contour of another cluster, obviously we get the erroneous results. Okay, this is about the maximum likelihood classification. Next, here this particular study area, I have taken a classified image, same study area classification using minimum distance to mean and maximum likelihood classifier. Apart, if I have checked the accuracy accuracy, whatever I have obtained for maximum likelihood, it is good when compared to minimum distance to mean. How can I say here? If you here focus on this particular highlighted part, in this particular highlighted part, I am having red pixels along with the yellow pixels. Here it is a misclassification is there. Mixed pixels are there. Because of the presence of the mixed pixels, the accuracy is not that much good in minimum distance to mean compared to maximum likelihood classifier. Here if you focus on this particular study, this feature, there is no red pixels. Okay, there is no mixed pixels, so the accuracy is good. This is about the supervised classification. Okay, not in all classes maximum likelihood works better. Based on our digitization, based on our algorithm used, we get the output. Okay, see you next. In next video we'll be discussing about the unsupervised classification. Bye.